看一下 instruction，它有 Windows version 和 Mac version。那就是得进去调。One sec。唉503。嗯，OK。哦，嗯excuse me, you are the 6184, right? Do you want to test the slice or yeah, yeah. 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 One second. This video, right? Does it have any sound? Okay. Yeah. Should have sound right here, right? Let me adjust that. Just 1 second.
Not only that, but draft one standardize the format of your reports and improve.
Yeah, from right here. Let me check if I can play that like really out loud. Oh.
At first reviews, you will notice this.
Okay. Right. So we don't have a like a speaker connect to this laptop. So when you play the video, I might need to like adjust the microphone like real time. Yeah. Yeah. So I will do it. Yeah, no problem. I will just sit in the front. No problem. Yeah, no problem. Hello，你是其中一个 speaker 吗？你需要过一遍吗？看一下有什么问题吗？对，对。 你有 Note 吗？
不，没有 note，
Anyway，
我直接讲就可以了。对，
行，
然后我感觉应该是没问题。
主要看一下什么字体啊，乱七八糟的。
我看看这个。
这个如果有
嗯
video 的话，我
嗯嗯
我得现场就是
嗯，
关一下麦，然后把这个打开，因为
没事，我这个 video 是没有声音的。
没有声音。
对对对，我当然没有了。
那行，
OK，对，这都正常。
嗯
OK，
，OK，
也挺好。然后我们这边的话是已经连上就可以是吧？要 share 吗？现在就聊。
连什么？
我说 Zoom，对。
我已经挂上，就
好，
是用我的 laptop。
行，没问题，
对
到时候就直接这样讲就可以
，OK，
是吧？OK，
对对对，那没问题。
嗯，
有回音的，因为那个麦开着，然后对，这个应该是 real time，这个应该是 real time。那个是有的房间是 black 的，对，有的房间是 black 的，然后如果你来找这个讲的话，扬声器是选择 real time，默认的，那就选系统。那应该是。我把那个存在算了。那你这怎么说啊？对，我听过这个。有回音是连麦走的100%，对。然后美国是都吃的。为啥我这个得拔出来，然后摁一下再吃。待会儿那个就是 host 会来回问这个。OK，那你一会儿做后面的。一会儿就是，如果要播放 video，然后 video 有声音的话，你得把这两个得关上，这个你配合的。然后一般的话，这两个是台上的麦，然后这个是 handheld，就这两个以前讲话的，然后这个应该是动，我在这清楚，因为我。OK，是。现场那个麦给关了吗
How much time your
？OK，
officer spends
现在
writing
就
notes? The data suggests that the average officer spends up to 3 hours per day on paperwork. Draft one reduces that time. In many cases,
hello。
based on body worn camera.
然后视频，现在又开开了。对，OK，不，好的，耶。Which one is this one? Yeah. Okay. Do you have any like video need to play?
Not really.
Okay,
Do I have
cool.
to?
No, I'm just checking
Uh-uh.
because
I
when you
try.
play the video, I need to mute the mic.
Okay.
Yeah,
I trying to deliver this video
Yeah.
tomorrow.
yeah, that's fine. That's fine. Hello 啊，大哥。哎呦，啊，这就是我电脑。就是前面的，因为他的电脑只有一个 Type-C 口。OK，你需要吗？还是怎么说？我觉得应该要这是 PDF 的 slide。 OK，
对，你有那个OneDrive吗？
有
你能打开？
啊，
你OneDrive，我就直接电脑上就拉到了。
行。等一下，就是他们传那个东西的 OneDrive 是吧？OK，which one？
LPG，
这个哈，
你就这边，
直接下下来就行了呗。
我是在网页就行，你
打开就行。Sorry。OK，
我这条他能全屏吗？我不清楚。反正我觉得你还下
没事，全屏。
他能全屏吗？不知道。
这个
还下下来了，
下下来，我应该已经下下来了。
对，
稍等啊，等会儿看。
是，然后应该是 F11能全屏什么的。
F11，
可以。under control 或者 command，然后
Command F11，
也不行。
let me see。
或者右键全屏 full screen。
full screen mode。
点了它
OK，cool，没问题啊。Yeah，come over。Yeah，please。
那么
这是必放。
OK，
啊，我们有 video 的时候我跟你说就行。24。这个我不知道，这个看后色是，哎，我几分钟然后让我看同学他们给我这个这个这不是单纯在学校我真不是从这样下。这个我们俩不清楚，其实我们俩在微大。你要小家。对，因为这个取决于 host 的控制时间啊。我们俩说实话就是往我因为我看昨天的时候我就每个人昨天我看见有多少个那个，这个应该是8个人吧，8个人，对，8个的话，你每个就算那应该15分钟。
那我们昨天只有4个，我们昨天只有5个
啊，
然后每个大概是20分。
对，
包括题。
应该没事儿，没有准备，因为我们只是这个单口，就够一个，别的没关系。对，8个，对。
第一个半小时的话，那个其实10分钟多一点。
差不多。是。你要想直接在 YouTube 上放，其实也可以。对，我把这个，对，我把链接插进去。那也行。哎，链接怎么插进去来着？对，哎，链接怎么插来着？Video。最右边那个 video 那块是不是应该能插链接？对，video online film。对的。Not quite sure。file online。啊哈。对。
还没。好，那这样我就会少讲一点。
看你自己怎么控制就行。OK，这也是有声音的，对吧？
对，有声音的。
OK，那你放之前我去调一下麦。
好，谢谢。
保存一下。好问题哈。
So hello everyone. Today I'm going to present a demo called HEAL, Healthcare Emergency for the Assistance System. So to start, let me give you a brief background. So nowadays in the Australia, we have like 8.8 million ED presentations during the 2022 to 2023, but there are only actually like 293 hospitals. So that means like we have like 30,000 patients to visit ED in this year. So clearly you can see there is like significant challenges due to this imbalance between the patients and the human resources we have at the hospital. So basically this imbalance will cause the delayed treatment and will also cause the higher rates of mortality and mortality. So after identifying these issues, we have two objectives. So firstly, we want to build a LLM-based multi-agent system to automate this critical workflow in the ED. And also we want to evaluate the performance of LLMs across under these scenarios. So let's have a brief look of our system. So as you can imagine, like when the patient just arrived at the ED, we want to do some like quick check-in, and the emergency department nurse will give the patient a appropriate category. We call the triage category. So this category will decide like how long the patient gonna wait at the waiting room. So we have the second stage called the monitoring mode. So basically, the main function of this mode is to monitor the patient's condition at the waiting room. And finally, the patient will transfer to the doctor. So in the first mode, we built a couple of agents. So firstly, we have a chatbot, which is straightforward to build a conversation with the patient. At the same time, we have the patient information collector to extract the essential information in this conversation. And after this patient profile is completed, we have a triage category classifier to assign a appropriate category for this patient. So after we pass the patient to the waiting room, we have another monitoring mode to monitor the patient condition change. And here we have similar agents as before, but we have two new agents. The first one is condition change collector, which will collect the patient condition change. And we also have a monitoring bot. This monitoring bot will just monitor the conversation to identify if there are any like urgent situations we need to report to the doctor, and the conversation will be ended immediately. So for each agent, we also design a couple of modules to giving them like the capability. So for example, we have the profile module to define this rule, the memory module to record the history, the conversation history, and also the agent can recognize the patient. The third one is the most important one, the knowledge module will integrate the corresponding standards in the emergency department. So here we mainly focus on the Australia ED standards to make sure the agent can make correct decisions when they're classifying the triage category. So finally, we have the action module to enable it's like to communicate to information extraction, etc. So after all this talking, let's have a look at our demo. You can see at the top, we have a patient ID for each patient. So this can identify like the patient information. On the right-hand side, we have a real-time updated dashboard for the doctor to monitoring this patient. So this information will be updated on this dashboard, but in like more concise and accurate version. We want to like to clearly describe the patient symptoms, etc. So maybe let's skip this a bit. So this basically like an information extraction process. Oops, sorry. Yeah, as you can see, after we filled all those critical fields in this workflow, the system will have a notice here like that this patient information has been collected. And as you can see here, the system assign a category for this patient. And also we will tell the patient the waiting time under this category. And if we switch to the monitoring mode, we'll try to build a scenario that the patient is waiting at this room. So basically, we have another field to record the patient's condition change at this time. So in this scenario, we made a case that the patient feel a bit better. So it's not like an urgent situation. We just need to continue to update their information. So yeah. And also like when the patient to indicate, okay, I want to end this conversation will be ended. And now, like, as you can see, the system make a decision that we just keep the exactly same category for this patient. It's still the category 4. Oh, sorry. And also, but if we imagine that we have another like urgent scenario, this is just a made up case here. So let's see, we type our ID again. So some urgent scenario, like the system will identify that, like as you can see, the category being escalated to the category 2. Okay, and we also do some experiments. As I mentioned, we have another goal. We want to assess the LLM performance under this scenario. So there are 2 questions we want to answer here. So the first is, how effectively can the LLMs extract those crucial information during this conversation? And another question is, what level of accuracy can LLM achieve when assigning these triage categories? So for a brief experiment setup, we've used emergency triage attribution kit. So in this kit, we have like around like 100 samples with like triage categories assigned by medical experts. So we do some pre-processing of this data set. Since this data set, you can imagine, is unstructured data, we want to classify this data set into like 2 types of fields. The first one is basic information, which includes some standard personal information like name, age. And we also have clinical info, which usually involves the patient's symptoms, etc. So basically, in the first experiment, we can see overall the GPT-4 Mini has the best performance in both basic information and clinical information extraction. And in the second experiment, we do something about the triage categorization. And we also did a bit ablation study here. As I mentioned, we've built a knowledge module. So we want to prove that, okay, the knowledge module is useful to improve the accuracy of the system's decision on the triage categorization. So in summary, we built this multi-agent system to automate this triage process in the emergency departments. And we also self-build the profiling, memory, action, and knowledge modules for each agent. And finally, we did some empirical experiments to prove the system's effectiveness under this scenario. So that's all for my presentation. Thank you. Is there any questions?
Yeah. Sorry. I've been into the emergency room for a few times for myself and for my friends, which I'm not be part of that. But so when you're in a situation like you need to talk to the nurse, and sometimes like they need to do some kind of a check, right? But I'm just looking at your systems, feel like you're asking the patient to describe what their feelings, without actually, taking the measurement to like things, because that could be a problem, because for some people, like when they get to an emergency, they can't really talk or express themselves like in that situation, right? So it's you think about, or it's a possibility like in the future, like it's, those kind of things can be connected to your system, right? Like that by this kind of medical conditions.
Yeah, I think that's a really great point. So currently, we're imagining like we're facing some human shortage situation at the emergency department. And I mean, like currently this system is not like too completed. Like we haven't integrated those, some monitor to kind of to detect, let's say the heart rate or anything. So I think like in the future work, we will integrate this. Yeah, for sure.
Yeah, that's great, because I know there's a lot of hospitals that they're trying to have this kind of interconnected, for the medical device, but that's another story. It's still got quite a long way to go. Yeah, thank you.
Okay, thank you.
Okay, good afternoon. My name is Xuexing, and I'm a first-year PhD student from the National University of Singapore. And I'm very happy to present our PhishIntel work, which is mainly about the deployment of the reference-based phishing detector. So this is a joint work between the National University of Singapore and the NCS Cyber Special Ops R&D. Well, phishing attack is a long-standing cyber threat. So if you search for the news about phishing, you may find that phishing attacks are almost everywhere. and it is causing tremendous amount of financial loss. Let's say for an email ad users, they won't really check the legitimacy of the URLs in their email very carefully. When they receive the phishing email, they will be very likely to be compromised. So that's why we need to have some kind of effective and efficient phishing detection systems. Going back to the research, what is phishing? As you can see from these two figures, it is very easy to tell that the right-hand side one is likely to be a phishing website because it shows the brand intention of PayPal using logos, but it does not use any legitimate domains of PayPal. Moreover, it requires the user credentials. These evidence make it a suspicious website, especially for the first two. The brand intention and the domain of that website is inconsistent. And in recent research, there is a type of the methods called reference-based phishing detector, abbreviated as RBPD. They have been regarded as the state-of-the-art phishing detectors. The mechanism behind the RBPD is similar to what I just described for the phishing website. So they will check the brand intention of those web page using some machine learning models, and then perform the domain verification with their knowledge base. This is some kind of rule-based approaches. The brand intention can be found from the logos from the web page screenshot, or it can be identified through the textual information, like in the web page HTML. A recent work called NoPhish leveraged this method. So you can see that for the past 4 or 5 years, there are a lot of these phishing detection methods published in the top security conference. But the thing is, in these research papers, they assume that the input data is available, thus leading to a very satisfying efficiency. However, in practice, the only information available is the URL. Take the email as an example again. We don't really have the web page screenshot and the HTML in the email content, right? So the only way to obtain this data is to crawl the web page using a web page crawler. But based on our observation, the crawling process can be extremely slow. Directly integrating a crawler to the RBPD will lead to unacceptable latency at the user end. So motivated by these problems, we come out with our solution, PhishIntel, which is a deployment-ready phishing detection system. The high-level idea behind the PhishIntel is that we design a fast, slow task architecture, which enable us to process a URL with different tiers. Basically, the direct outcome is that we ensure the instant response at user end and also efficient URL filtering while maintaining the zero-day phishing detection capability. Besides, the system can also process the URL in parallel, which significantly improves the efficiency. So, okay, the first level of our system is a fast task workers. Basically, it processes the URL with some fast and simple matching. For example, if the URL has been marked as phishing in some publicly available blacklists, and then there is certainly no need to check those URL again, because the public phishing URL blacklists usually have high precision. So all the URLs basically all the URLs in the blacklist should be a real phishing website. And also, if the URL has been processed by our slow task workers, which I will introduce later, we can just directly return the result in the saved in the result cache. So this checking can be executed very quickly. And if we find the match in this checking, we can immediately return the result. Otherwise, we can send the URLs to the so-called slow task queue to wait for further processing. Now we have come to the second level of our system. Simply speaking, the URL without an immediately available result most likely need to be analyzed by the reference-based phishing detector. So the URL will first go through an online blacklist checker, which can further avoid repetitive analysis. Then, if there is still no match, the URL will be crawled and fed into the reference-based phishing detector. The analysis result from the RBPD will be saved in the result cache, such that if the same URL requests come again, we can immediately return the results. We have also conducted some performance evaluation for our PhishIntel system. The first observation is that the response latency of PhishIntel is very low, proving that the fast low-task system architecture is efficient, and it is definitely much faster than the sequential implementation. And the second observation is that those blacklists help filter out around 1/3 of the phishing URLs, which do not require repetitive analysis. However, we found that there is still a portion of the URLs cannot be blacklisted, which we call zero-day phishing. And that's where our RBPD can perform proactive detection. Overall, the efficiency of our system is greatly improved. Now that we have an efficient system, we have developed 2 applications based on PhishIntel. The first one is a phishing intelligence platform. In this platform, you can submit your customized URL list as a text file for PhishIntel analysis. Let's say after you click the button, you will receive a result immediately, which tells you whether the URLs are phishing or not. In the case that some URLs requires further analysis, the platform will also show a status of in queue, meaning that they are pending analysis. So you can also submit the same URL request again to check the updated status. Where more URLs may have completed their analysis. We have also developed another application that works as a plugin in the email system. In our demonstration, it is the Microsoft Outlook. Specifically, this plugin equips the Outlook with an additional button in the menu bar. If you would like to check the benignicy of the email, or in other words, you want to see if there is any phishing URLs within the email, you can just directly call this plugin. And basically, it will extract all the URLs in the email and automatically send them for PhishIntel analysis. Similarly, there are also 3 possible status: phishing, benign, or in queue, which will be shown in the plugin panel. To quickly summarize, these 2 apps benefit from the efficiency of PhishIntel, resulting in a more user-friendly phishing URL detection. So here is a takeaway for our demo project. If you are interested, feel free to come to our poster session tomorrow. And if you would like to know more about our phishing research, there are 2 QR codes linking to our recent research papers. Thanks for your listening and patience. Feel free to ask any questions if you have.
Yeah, thanks. Great presentation. Actually, I'm doing similar study. I'm doing misinformation detection. So we're doing detection by provide evidence to take a fake one, like a misleading document and a misleading information, like a harmful speech. But what I found the most difficult part is you can hardly decide what's true or what's false. So, but in the phishing, you have the correct label, like the domain can be shown, like AU post show on the URL. But for misinformation, you don't have the true label. Have you concerned about if the misinformation add the metadata like a URL to the misleading document? Is that be more hard to detect?
So the task is misinformation detection or phishing detection.
Yeah, misinformation detection. Because also found there are a lot of misinformation. They not only just publish in the document the content, they also add the URL to that misinformation. So that's why it makes it hard to detect them before.
Okay, maybe let me rephrase your question again. So you are saying that if some phishing URLs contain in the misinformation, right? And then the task is to perform the misinformation detection. Okay, actually, I'm not quite familiar with the misinformation detection, but I think that if there is a malicious URL in some content, let's say no matter it is misinformation or not, if there is a malicious URL or phishing URL that can show you some evidence of the kind of it is basically saying that we need to pay attention to this piece of message, right? So In that case, I think the phishing URL can play as a side information to assist the misinformation detection. But in terms of how the specific details of those integration, I'm not quite sure. Yeah.
Thank you.
Yeah, thanks.
All right, cool.
Is the speaker here? If not, let's continue to the next one for now. Yeah. It's a speaker for 6111 here. Oh, okay. So 6184. Yeah. Sure. Okay. Just 1 second.
Good afternoon. My name is Xin Liu. I'm Senior Research Scientist at Axon Enterprise. Today, I'm very happy to present our work on behalf of the team. This auto-drafting police report from noisy ASR outputs, a trust-centered LLM approach. So give you some background about this product or projects. We call this product Draft1. It's a narrative assistant for police officers. The background is US law enforcement face a lot of challenge. One of the challenge is they have very high workload, and actually 40% of the time of their time spent on report writing. So we try to use AI, especially large language model, to help them reduce their report writing time to mitigate this problem. And there are potentially other benefits of using large language model or AI as to help them. One is standardizing the police report writing, and also it's going to enhance the transparency and fairness. Also, and most importantly, we want to reduce the report writing time. The challenge of using large language model to build this product is, directly use large language model or traditional challenge with direct use of this large language model is how do we maintain the trust and consistency in report generation, and how can we make sure we can preserve all the relevant information in the report. So in our product, our approach is to first we build our evaluation. We build very strict evaluation to evaluate our product. Second is we keep human in the loop in the product design to make sure officer can provide the essential incident details before we start generating this draft report. Second is we have this draft review and refinement section. So we emphasize this is not a report for the officer. This is a draft report. So the officer has to review, edit, and sign the draft before they can submit, and that's their report. And what we provide is only a draft report. So this is an overview of our system. We have this body camera, and the body camera recording will be uploaded to this secured evidence management platform, and it will be first transcribed into transcript, and then we go through this large language model and then generate this draft report. So let's take a look of our product. Yeah.
Time your officers spend writing reports. The data suggests that the average officer spends up to 3 hours per day on paperwork. Draft one reduces that time, in many cases cutting report writing time in half by automatically drafting police report narratives based on body-worn camera audio. Draft one drastically reduces the time your officers are spending writing reports. It's an incredible force multiplier that enables you to get more out of your existing workforce while boosting morale. Not only that, but Draft One will also standardize the format of your reports and improve the overall quality of the reports being created by your agency. Was there one? Marcus. Okay, all right, Marcus, you have a good day, okay? Once the report has been fully generated, the officer will insert the text into the Axon report writer where the report can be edited. At first glance, you will notice a few more safeguards that we've instituted to ensure the report's accuracy. The Axon artificial intelligence model being used has been instructed to stick to the facts and only generate text based on what is confidently understood by the AI. For interactions that contain ambiguity, Draft One will request that the officer insert additional observations that he or she may have noticed. If the officer attempts to submit the report without addressing these requests for greater detail, Draft One will not move forward until these requests have been addressed.
Uploading your damaged property reports, those, he really does a good job of raising them. You come on the shop with an impact, you don't come on the shop with impact. So this AI feature, I'm super excited. Once they use technology, they help it controls to their day-to-day operations. And then there's what I'm most looking forward to is the increase that this technology provides from line level to member level. Ultimately, we are here to serve the community and this help.
So we did, as I mentioned earlier, we did some evaluation to make sure the products having good quality. So this evaluation involving real officer feedback, also extra-light double-blind study. So in the real officer feedback, we got the feedback is on average about 21.93 minutes saved per report, roughly 41% of time reduction. And on average, we receive 4.46 out of 5 in real officer ratings. We conducted like double-blind study with 113 pairs of report generated by only without using our system. As you can see, we significantly improved in terminology and coherence compared to just manually written reports. So that's all about today. I'm happy to take any questions. And tomorrow at 12:30, we have this. I will set up this demo. You can try on the real product, the user interface. I have prepared a few videos. You can try to generate some reports. Thank you for your attention. Any questions?
Good afternoon, everyone. Thanks for joining this session. I am Chen Kunhe, a PhD candidate from RMIT. Today I'm glad to show our work, Raycars, a responsible and extendable context-aware recommender system. This is a brief outline of this talk. So first, we will present the core concept behind our work. Then we will highlight the what makes Raycars novel and how it differs from the existing systems. Finally, we will show how to operate the system with a short video. So on social media, there is a lot of context like time, location, user relationship, and content category. So we use the CCIG model to selectively combine those content with corresponding context. And then check the how well they match a user's interests. Then we apply an active learning filter to involve users in the recommendation process. Users are able to give real-time feedback to improve the diversity of the recommendation. Then we apply the large language model to generate flexible and clear explanation to make users easier to understand the recommendation. As for the novelty, the CCIG model not only captures media content and context, but also can work with different types of media and applications. The CCIG representation is quite compact, making the user item matching fast and accurate. We also use a uniform partition strategy to balance the workload in distributed systems. To make sure the system can run well with large amounts of data. The system is also built on MongoDB, which is specifically for dynamic and real-time media. Then we use active learning-based filters to reflect the user's reaction on recommendations. Finally, the large language model will give clear and user-friendly explanations to make the recommendation solid. So Raycars stands out. It's not only for fast and accurate, but also it's flexible and user-friendly. The CCIG model capture both content and context and can easily adapt to different applications. We also designed the data handling and the database specifically for dynamic media. So making sure that they can run well with different data size in real time. We also introduce the user-guided filters and explanations, which ensure the system is responsible and transparent. So here we list the key environment settings and deployment setup steps. The system mainly has three interfaces. The homepage shows the generalized recommendations, and after signing in, users can access the personalized results. And generally, this system supports two different recommendations with 4 options. And we prepare a short video to show how to operate the system.
One second. I don't think they're
Oh, well, something wrong with the video player. So thanks for your attention and any questions?
Good afternoon, everyone. I'm Yu Tao Wu. You can call me Oscar. I'm second year PhD student from Deakin University in Australia. Today, I'm excited to be here with my supervisor, Xiaoliu, to introduce our demo system, Clear. So Clear is a climate change policy retrieval and summarization using large language model. So you can think Clear is something like question answer and the summarization, but it works from both ways. It helps public, especially people who live in rural area, to understand the coverage of current existing policy document. It also provides insight to local government to review their existing climate change policy. Because climate change is can be recognized as a very traditional study problem in media of communication, so we can target our study from the design questionnaire. So each question is designed with the help of domain expert who has background of media communication. We're trying to explore current landscape of climate change towards to rural community. We study rural community in both developing country, Indonesia, and the developed country, Australia. We achieve this by collaborating with the Gajah Mada University in Indonesia. I also provide a QR code which you can scan to explore fully version of the questionnaire and the result. So the most identified problem is most people and the public, they don't know where to find corresponding policy document to address their unique challenge. So for example, people from living in the coastline, they may concern about the heat wave. And people living in country road, they may concern about agriculture. But this is very difficult to find such the policy. I give Australia an example. Australia has more than 500 local government. They are able to publish the policy documents. But each local government have different website and the form of the policy document presenting like PDF or YouTube link, even the small announcement and audio. So there is no structured database you can interact with. So it's not like we can just simply input our question into Google search and get a result. So that's the main issue we want to address. We want to collect the structured database to answer users' questions, especially for people living in the rural area. So we design the clear. And the typical example of such question can be conveyed by this slide. For example, people from city of Sydney, he's interested about heat wave. He also concerned about what current local government is doing about this. And the right figure is we're trying to input such question into the corresponding website, but there's no any information content that truly answer users' question. So what we proposed the query interpretation model is fine-tuning on Llama 3.2, 3B. We collected 3 manually annotated dataset. So given any questions, we are able to extract 3 components: its location, intent, and topic. So all the following application is built upon these 3 extracted parameters as LIT. So this is the overall framework of Clear. So given any question like here, Q, we execute the query model and we extract the location, topic, and the query. And then we also have 3 different data sources. We have our collected data source. We also have Wikipedia data and the census data. And we perform summarization based on different combination of the query component and the data. We can generate the communication report. Basically, it's like the distribution of the community age and the people's salary, even the household family members. We also generate the policy reports. It perform retrieval augmented generation. We select the most relevant policy document to answer users' questions and generate the policy report. So this is the ideal situation, but in most cases, there is no any policy the content truly answer. So that's why we also design additional delivery modules. So in some cases, we couldn't identify any useful information to answer questions. We generated the feedback email and all the information like a subject and the receiver email address and the content all generated automatically by the Clear module. You just need to click the send button and we will send the email to the corresponding local government. So for example, this is a truly example we collect the data from. So given any location parameters, we mapping corresponding Wikipedia page, we identify the geographic data. And from the national statistics website, we can identify data like people, family, and the household. And also this is the generated feedback email. You can say all the content and information generated by Clear. And we also launched our web platform website. There is more what we show today. We including data. We have the survey result. We also have the chatbot. We also have the validation tool. And this is our website link. So next, I will play the video about our web platform.
has been blocked just to enable.
Welcome to the research project website, Building Resilience in At-Risk Rural Communities Through Improved Media Communication on Climate Change Policies by DK University, Australia, and the University of Gajah Mada, Indonesia. The website offers a variety of project tools, including a policy overview, policy database, data visualization, and a climate change Q&A system. These tools aim to enhance individuals' understanding of policy intentions and build critical policy evaluation capacity among at-risk rural communities in both Indonesia and Australia. Our media team manually searches for climate change-related laws and policies using 19 major keywords derived from 3 levels of government: national, provincial, and district. Based on the collected policy documents, we developed a simple yet effective Q&A system powered by large language models, LLMs. We extract content from policy documents and convey it into the LLMs response to user questions. To ensure the reliability of source information, we also display the original PDF documents that guide the system in providing answers. At this stage, we map a few parameters in the map interface to transform complex climate policy data into clear, actionable insights. The government level which policy belongs to, whether the LGA local government area is rural or not. For example, we are now browsing a few regions and locate the block local government area. As you can see, manually extract and detailed policy information will display in the placeholder, government level, LGA type, contact, policy document PDF, extracted actions, etc. Similarly, as you can click the map interface to switch into Ganawara, another rural local government area, and identify their policy actions and climate change strategies. The remaining 2 menu items are about us, which includes all the researchers and contributors to this project. And our previous multilingual COVID-19 fake news detection project. You can find our fake news detection tool and the COVID-19 fake news dataset there. We also promote our website and welcome to the research project website.
Okay. Yeah, that's pretty much what I'm going to show today. Thanks for listening. Any question? No.
Good afternoon, everyone. So welcome to our demo session. So in this talk, we'll talk about the research project that we did with our coursework students, Yongcheng Zhang and Rui Hong. So this talk is about exploring the potential of graph neural networks-based methods for general linear programs. So which is not about LLMs as what everyone did here. So, but anyway, I'll continue to try to let you guys understand what we did. So, linear programs is something about optimization. So which means that, for example, you train your LLMs, you have your objective function. So objective function will be something like minimize something. And then in the optimization function, you generally will have the constraint as well. So which means that we want to do something about using learning-based methods to deal with the optimization problem like this. So what we did here is that we try to frame the optimization problems into graphs. Okay, so we want to transform this kind of equations, mathematical formulas into geometric things like graph. And then, for example, we can transform the variables that we can optimize into some type of nodes, and then we can also transform something called dual variable nodes, so which is something within the optimization problems. And we can also transform the objective into the nodes as well. So which means that we will have a logic of transform the different variables into different nodes. And then we'll also have edges. The edges would come from the A or C, that where A and C are just vectors and matrices that about the coefficients of your optimization problem. So basically what we try to say is that we have optimization problem, and then we want to transform the mathematical problems into graph. And then what we want to do is that we will try to use graph neural networks to learn this graph and then try to approximate the solution of these kind of linear programs. So we have some examples here. For example, on the top left corner here, we can see we have this kind of optimization problems, and then they can somehow be transformed into a graph on the right hand side like this. Or we would also have some different types of graph, and they have different variable types. So what this demo paper do is that most of the current methods, they mainly just focus on training and testing on the same type of linear program problems. But we are trying to see whether we can combine multiple types of linear program problems together, and then we create a larger data set, and then we try to see whether the learning methods can actually be generalizable. And then we also compare different methods. I don't want to talk too much into detail of these methods, but basically the background is that when we are dealing with some cross-disciplinary problems where industrial sectors would involve the optimization problems, this kind of learning-based methods is somehow interesting to do, because they sometimes want to have a faster solution. So that is why we want to do this. And then the overall pipeline of this demo project is just to like this relatively straightforward. On the left hand side is the optimization problem, and then in the middle, in the colorful things here, we transform the optimization problems into different types of graphs. And then after we have the graphs, we'll put this graph into different graph neural network learning based methods, and afterwards we will have the solution of them. So this graph, we can say that actually if you didn't know the concept of bipartite, which means that the nodes have two types, and then tripartite means that the nodes have three types. So basically they're just indicating different types of graph. And what we do is that we evaluate the performance. So we can see that for one of our baseline method called SIB, they can change on some medium-sized problem. So what we say about medium-sized problem is that we don't have too much constraint. We don't have too many constraints. We don't have too many variables there. And we can see that when we train the model on this so-called medium-sized problems, they can actually generalize well on small size and large size problems. But what if we use another type of baselines called LTP? They can actually not generalize well based on some previous methods. And then we also somehow evaluate all of these data sets with another baselines called IPM GNN. And what the statistics show here is just basically say that this IPM GNN method can actually work well, and then it can work with different size of the optimization problems. And we also do some evaluation, like when we fix the GNN model size. All right, GNN model, they're actually neural network models, and then if we fix the model weights, the dimension of the model weights, it doesn't mean that when you always have more data, it will generalize better. So this just to say that in some situation, in the medium number of data, then the model will obtain a better results. And the conclusion of this demo project is to say that our GNN actually can find a good basis solution for linear programs. And then with this basis, the learning-based method, optimization method, can also still be challenging, but they are still working okay-ish. And then directly solving these linear programs with the learning-based methods could also be a promising direction. And here are the reference, and we also have links to our demo projects, which in which you can directly upload some optimization problems with lots of constraints and variables. And then we also have our code, everything over open source here. And thank you, everyone. Thank you. If there are any questions, please let me know. If there are no question, then thank you.
Next presentation, and we have one slide. I don't have slide. I will post the presentation. Yeah.
So should I?
Yeah, just my poster disappear.
Okay, yeah. You upload to Wi-Fi.
Yes.
Just one second. Try it.
This one.
This one.
Yes. Also the video shows.
Yeah. 1 second.
Yeah.
Bye.
It's not clear. It's okay.
Okay.
Yes. Hello everyone, thank you very much for joining us today. I need to apologize. I haven't provided any slides today because I just found out that I should have uploaded slides, but this is what I have, my poster presentation. Well, anyway, I'm excited to share our research about which is about Trffc, which is a model that makes traffic forecasting faster, scalable, and easier to interpret. But to make it more understandable, let's talk about the problem. We know that the modern traffic systems are complex, and we model these systems with graphs. And the nodes are the sensors on the roads, and the edges are the connection between these sensors. So these graphs are huge, dynamic, and also dynamic and often noisy. And it is very hard to work with these type of graphs. So traditional models struggle with this. They're slow, they miss important like dynamic and evolving patterns. And this is the challenge. So traditional models struggle with this. They are slow, they miss important patterns, and they require a lot of computation. That's where our models comes in. It is a reinforcement learning based system that learns to simplify traffic graphs, and it selectively remove edges, those edges or connections that are less important, but at the same time it keeps the core structure and the dynamics. This makes forecasting faster and more scalable, and it actually improves accuracy by removing noise. Under the hood, as you can see here, we model the graph using GCNs to capture spatial relationships, relationship between nodes, and GRUs to capture how traffic changes over time. Then a reinforcement learning here, reinforcement learning agents look at the edges and decide whether to keep it or prune it. It learns from a multi-objective reward function that balances three things. The first one is that we need to keep the network connected, make sure that after removing an edge, the network will still be connected, all of the most important nodes. And then the second one is to preserving high traffic routes, and also retrain and keeping important intersections, the nodes with high influence. So here you can see that we have I haven't put the reinforcement learning structure, but this is basically what we've done with the reinforcement learning. And we also make use of prioritized experience replay. So the model learns faster by focusing on the most impactful pruning decision. So to make this all user-friendly, we provided an interactive dashboard. You can load or choose data sets, traffic data sets that you have, and like METR-LA, which is traffic data sets about Los Angeles traffic system, and we can choose how much we want to prune this system, and then instantly you can see the updated graph. You can explore individual nodes here and view forecasts and even read GPT narratives to better understand how the graph has been pruned and understand the traffic forecasting. Well, in our test, TRFF was able to shrink the graph size by 50%, while we improved the forecasting accuracy, especially on large complex traffic network like Metro LA and Thames Bay, which are related to big cities like Los Angeles. So in short, TRF helps you forecast traffic more efficiently and simplifying the problem, both literally and computationally. So I've also provided a video which can be shown here.
That's all.
good.
Do I have the presenter for the multimodal workflow for advanced visual understanding here? If not, we can call it off. And thank you everyone to attending this demo session. All right, thank you.
Mm. 这个我这些我都不是特别清楚。你为什么？哦，没有，我不是特别清楚，我说实话啊。